So now we will start with this combination, nominal or ordinal independent variable or more independent variables, but only nominal or ordinal, and nominal or ordinal dependent variable. All analysis today we will make twice. First, we will make analysis with one independent variable, and then we will add more than one independent variables. So I will start again with the presentation. Measures of association between nominal and ordinal variables. And the combination, the dependent variable will be this variable optimism, but optimism R, where we have three categories: below the norm, in the norm, and above the norm. And the independent variable will be Marischal status. So in PSPP, I must open the file. In SPSS and in PSPP, there is an option here in file, recently used data, and from here you could open quickly the last files, usually the last 10 files, but for now there are only 2 files, and I will open this survey, our basic data file from yesterday. So after that I will press analyze. After that, again descriptive statistics, but now crosstabs. Here we have 2 fields, rows and columns. It doesn't matter where we will move independent and where we will move dependent variable, but usually we move dependent variable in the row. So I will find here optimism R, yes, and we'll move to the row. And usually independent variable we move to column. So Marischal status, here, I will move it to column. So this is the first step. I will press OK. Sorry, I forgot. Before OK, I will press cells and choose only column percentages. I will uncheck row and I will uncheck total because the better choice is to check this option here, which correspond to the independent variable. Since we move independent variable to the since we moved independent variable to the columns, here is better to choose column. If if the independent variable is moved to rows, then here the better choice is a row. So continue and then OK. And here we can see the result. Here in this table, in each column, we have distribution of optimism, and we must compare the columns. We must compare percentages in the columns, and here we can see that, for example, in the group of separated, the percent of persons below the norm is highest among all groups. And also, for example, in the group of widowed, a percent of person above the norm is highest among all groups. So, obviously, there are differences between groups, between different marital statuses. And since there are differences, that means that there are relation between marital status and optimism. But when we work with samples, these percentages are estimations. And yesterday I said that when we work with samples, there is sampling error. Always there is sampling error. So the question is again the same. Are these differences larger or smaller than sampling errors? If the differences are smaller than sampling errors, that means that these differences are not statistically significant. And if these differences are larger than sampling errors, that means that these differences are statistically significant. So we need, again, testing of statistical hypotheses. And here, the method is called chi-square. Here we have chi-square. I will open again whiteboard to write. This is Greek letter chi. This is chi and chi-square. I wrote here chi-square because there are different pronouncement of this letter. You could hear this letter as chi-square or chi-square, but this is the Greek letter chi, and the incorrect pronouncement here is chi-square. And again, we have here significance level. And again, the rule is the same as yesterday. If this significance level is smaller than probability for type 1 error, usually 5%, then we accept alternative hypothesis. And if the significance level is larger than 5%, then we accept the null hypothesis. In this case, the significance level is 0.3%, which is smaller than 5%. So we must accept the alternative hypothesis. That means that the differences between Marischal statuses are statistically significant, and that means that there are relation between Marischal status and optimism. And this was the first task, the first question about the presence or lack of relation. Second task is to analyze the direction of the relation, but it is possible to define the direction only when independent variable is ordinal variable. Because yesterday I showed that there are three possibilities. If independent variables increases, dependent variable can increases also, or can decreases, or can goes up and down. But in all three cases, independent variables increases. However, if the independent variable is nominal, it cannot increase. Only if independent variable is ordinal, only then it can increase, and only then we can analyze direction of the relation. So in our case, we have here nominal variable, different Marischal statuses, but here we have not order, and this independent variable is nominal, and we cannot analyze direction of relation. But for example, we could change the independent variable, and for example, to take education, level of education. So I will repeat, analyze descriptive statistics, crosstabs, and then we'll move Marischal status to the left, and we will move education in the field columns. And then OK again. And now we have percentages for each educational level. Unfortunately, here significance level is 52.4%, which is larger than 5%. So we must accept the null hypothesis. That means that there is no relation between educational level, between education and optimism. But for example, for the analysis of direction, I will show you how to analyze direction when the independent variable is ordinal. So here we can see increasing of the independent variable, starting with primary education, some secondary, completed high school, some additional training, completed undergraduate, and postgraduate completed. So in this direction, from left to the right, independent variable increases. And we must see the direction of change of percentages. So here we can see for the this category below the norm that first percentage increases, after that decreases, after that increases again, after that decreases again, and again decreases. So we have situation independent variables goes up and down. I will repeat here 3 charts from yesterday. This was the first situation, the second, and the third. So there is no direction. Since the independent variables goes up and down, that means that this relation has no direction. For the next category, for the category in the norm, we can see here increasing, increasing, decreasing, again increasing, and again increasing. So generally speaking, when the independent variable, when the indication increases, then a percentage in the norm also increases, with one exception here for some educational training, but generally they are increasing, there is increasing in the percentages of this category. For the third category above the norm, we can see decreasing, 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 increasing, and again decreasing. So generally speaking, when the educational level increases, then the percentage of the category above the norm decreases, again with one exception for the completed undergraduate. But generally, there is decreasing in the percentages. So in such way, we can analyze the direction of relation. And remains the last task to measure the strength of the relation. Usually, for this task, we use coefficients, different coefficients. And here, we will use one coefficient called Kramer's coefficient or Kramer's V. So I will repeat again, analyze descriptive statistics crosstabs. We will move education to left, and again we will move marital status to the right. And here in statistics, I will choose phi and Kramer's V. We need only Kramer's V, but these two coefficients are together, and I will check here. Okay. And then we have here an additional table for this coefficient, and we can see that the value is 0.19. Usually, these coefficients for the strength of relation are in interval between 0 and 1, and values close to 0 show weak relation, and values close to 1 show strong relation. In this case, 0.19 shows weak relation, but let's see here in the presentation. So there is association, relation between malicious status and optimism, and usually we divide this interval between 0 and 1 in 3 parts, and if the Kramer's V is between 0 and 1/3, 0.33, then the relation of the association is weak. If the Kramer's V is between 1/3 and 2/3, then the association is moderate. And if the Kramer's V is between 2/3 and 1, then the association is strong. So in our case, the value 0.19 is between 0 and 1/3, and the association is weak association. So this was the analysis of relation between nominal and ordinal variables with only one independent variable. We will continue with more independent variables, but before that, I will show you charts. Unfortunately, in PSPP, there are not charts. These charts are not exist in PSPP, and I will show only in SPSS here in the presentation. The charts is bar chart, but stacked bar chart, and it looks like in this way. So here we can see the same as in the table. I told you that, for example, in the group of separated, the percent of persons below the norm is the highest among all groups. Here in the chart, we can see the same. In the group of separated, the percent of persons below the norm is the highest among the all groups, this blue bar. And for example, in the group of without, percent of persons above the norm is the highest, again, among all groups. And here in the chart, this bar, the percent of persons above the norm in the group of without, is highest, is largest among all groups. So let's now add only one new variable, only one new independent variable. In our example, it will be gender or sex, but in SPSS, here there is additional field for layer. In PSPP, there is not field for layer. So if I choose here analyze descriptive statistics crosstabs, there are only two fields, rows and columns, but there is no field left. However, we could perform this analysis, but first we must divide this sample into two groups, and for this purpose I will choose data, and then we'll choose split file, and I will split file by gender or by sex. So here I can choose compare groups or organize output by groups. It doesn't matter which option. And then move sex here, groups based on sex. After that, I will repeat the basic analysis, descriptive statistic, crosstabs, and only press OK. Now we have results separately. Here you could see split values, and the first group are males, and here the second group are females. And we must compare Kramer's V, this coefficient. So in the group of males, I will write here males Kramer's V is 0.23. In the group of females, Kramer's V is 0.22. 0.22. That means that in both groups, the relation between marital status and optimism is almost the same. And that means that this additional independent variable, in our case, sex, does not influence the optimism, because the difference between these two coefficients is very small. So again, we could make charts here, but again only in SPSS. And this is the chart. Again, we can compare groups. We can compare marital statuses within the group of males and within the group of females. But now we can compare both groups. We can compare males and females. And here we can see some differences. For example, in the group of males, there are no widowed. Only in the group of females, they are widowed. Also, in the group of males separated here we have in the group of separated males we have persons below the norm, in the norm, and above the norm. But in the group of separated females, we have only two groups, only below the norm and in the norm. So there are differences between two groups, between males and females, but these differences are small. And this parameters V, these two values of parameters V in two groups show that these differences are small because the difference between 0.23 and 0.22 is very small. So this was the first combination. Of course, here you can add more than one additional variable. So if you want to add more additional independent variables, then in data split file, here in this field, you can move more additional independent variables, not only one, but for example, one is enough. So, questions? No questions, okay. I will stop recording.